Hello, everyone, and welcome to the second semester of algebra. I am Miss Morin, and I'm going to go through Khan Academy this semester and see if that helps everyone. So this week, we are working on Unit 9, and we're going to work on doing 7 squares. So let's go ahead and get started. So throughout the week, this week, you should be having 7 squares done in Khan Academy if you're using this curriculum. So extend arithmetic sequences. So basically, we just want to find the pattern here. And so what's the next term? Okay, so if I go from 1 to -2, that means I'm actually going to subtract 3, right? So 1, I have my number line here. Let's see if I can get that unhid. I have my number line here. And then I have -2. So if I'm here, I'm going to subtract 1, 2, 3. So -3. And then how do I get from -2 to -5? I would subtract 3 again. So that must be the pattern. So the next term would be -8. And that's right. Okay. So what's the next term? Let's see. To go from -7 to -3, I'm going to add 4. So I'm going to write +4. And then to go from -3 to 1, that's same thing, +4. And then 1 to 5 is +4, +4. So if I were to add 4 again, then I would get 13. So we're just, okay, this one's pretty easy, right? 0, 2, 4, 6, 8, right? Add 2. And then -6, -3. Okay, so I'm adding 3. And I'm adding 3, 3, 6, 9, 12. So 9. That's the first square. Pretty simple there. Let's go ahead and do square number 2. Okay, so these are arithmetic sequence formulas. So A of 1 equals 20. That just means that the first term in our sequence is going to be 20. So we want to find the third term. So what we're going to do is we're just going to take this formula right here, and all we're going to do is substitute 3 for n. So I'm going to write A of 3, and that's how we read it in math. A of 3 equals A, and then n minus 1. So n is 3 here. So 3 minus 1 minus 17. So this equals A sub 2, A of 2 minus 17. Okay, so we need to know what A of 2 is. So A of 1 is 20, and we're going to subtract 17. So it must be 20 is the first term, then minus 17 would be 3 is the second term, and then the third term we minus 17 again, and then we get negative, let's see, 17 minus 17, oh, plus 3, right? I forgot what I'm doing here. And so I get 4, negative 14, right? So negative 14. So it should be negative 14. So let's go ahead and try that one. Negative 14. Oh, it even has a calculator, right? So we could have just show the calculator. Oh, it's not working for me. Oh, right here. So let's see. Negative 17 plus 3. I could even come on here. Negative 17. Negative 17 plus 3. And that's negative 14. So that should be it. All right. Okay, so we want to find the 16th term. Okay, and so we don't need A sub 1. So A sub A of 16 equals negative 6 plus 3 And then we have 16 minus 1. So -6 plus, oops, I don't know why I wrote a 3 there. That's supposed to be an A. A of 15. Right, so, and look, if we're stuck, we just show related video, article of video. Let's go ahead and click that button. All we have to do is plug n equals 16 in the formula to find the 16th, and then we get another hint. And then, 3. I did write the right thing. 3, of course. Okay. Mm-hmm. We're going to use my eraser tool here. We're going to erase this part. Okay, this is 3. 3 times 15 is 45. So -6 plus 45. And then that, of course, equals, if it was -6 plus 45, that would be 40. So we just need to subtract one more. So that is 39. 39 here. All right, so let's go ahead and plug in 39. And of course, they give us the answer there too. Okay, same thing. So find the fourth term. So this one we are going to have to do that counting because we have this b in our formula here. So I know I'm going to need the first term is going to be -7. And I'm just going to add 12 each time. So -7 plus 12 is going to be 5, right? And then plus 12 again is 17. And then plus 12 again is going to be 7, 8, 9. So 29. So 29 should be my answer. 29. All right. And then the fourth term. So I don't have any A's in my formula, so I can just plug in 4 here. So that's what I'm going to do. So -6. So get our notation right. A of 4 equals -6 minus 4 times 4 minus 1. And then that is -6. Then I have -4 times 3. And then -4 times 3 is -12, right? So -6 minus 12, which is -18. So that's going to be my answer. -18. All right. Okay, so there's a variable here, and I just need the second term. So I just look over here. I'm going to add 10 to every term. I don't even need to write anything down because my first term is -20, and all I'm doing is I'm just taking that and I'm adding 10. So -20 plus 10 is -10. So that one was super easy. All right, so -7. Oh, again, no C's, right? Here's my C of n. No C's in my formula, so I don't need to write out every term. I can just plug in number 4 in there. So C of 4 equals -7 plus 6 times, I'm going to stick 4 right in there, 4 minus 1. Okay, so 4 minus 1 is 3. 3 times 6 is 18. So go ahead and skip steps. If you can do them all in your head, that's totally fine. And then -7 plus 18 is +11. All right, so that's going to be our answer here. Okay, so I do have, see, I have a C here and I have a C here. I have C's in my formula. So that means I am going to have to write out every term. And I want the third one. So my first term is 6. And what am I doing to it? I'm going to subtract 16 every time. Okay, so 6 And then I'm going to have subtract 16, which is minus 10. And I need the third one. So subtract 16 again, minus 26. So that's going to be my answer here. Minus 26. Negative 26. So that I got an orange there because I asked for a hint on there, but that's okay. Orange squares are just okay. You at the end of the unit, you can actually take a chapter test and get rid of any orange squares that you want. So if you get an orange square, that's okay. Just keep going. Okay. Remember, we got to get to 7 squares in throughout the week. So feel free to watch this video in pieces. But okay, complete the recursive formula of the arithmetic sequence. Okay, so now they're giving us the sequence and we have to determine what the formula is. Okay, so we need to know what the first term is. Well, that's easy, right? That's negative 15 right there. So negative 15. So easy on that. Okay, so this is my formula. The n minus 1, that means take the one before. If I want the second term, I'm going to take the first term. So take the one before, and I'm going to do something to it. So what is this pattern doing? Okay, so negative 15 plus or minus what equals negative 11. Okay, so I'm adding 4. So add 4, then I get negative 11. If I take negative 11 and I add 4, I get negative 7. And if I add 4, I get negative 3. So certainly I'm going to be adding 4 to each one. All right. So this is just like a big puzzle, right? These are sequences. Okay, the first term is negative 16. All right. Now, what is the pattern? Okay, look, you can even cheat. There's even a calculator, right? Negative, let's find out what the difference is between negative 33 minus 16, right? Okay. Oh, we want the opposite sign. Negative 33 plus 16. Okay. Negative 17. So am I subtracting 17 each time? So that's what I want to know. If I have negative 33, do I subtract 16, 17? That, yes, then I get negative 50. Okay, does it work again if I do it again? Negative 17? Yes, it does. So it does have a plus here, but I am subtracting 17 each time. So I need to make sure I put negative 17. All right. We got it. Okay. So what is the first term in the arithmetic sequence is negative 3. And then what is the pattern? Okay. So negative 3 to go from negative 3 to negative 1, I'm going to add 2. So does that work with 1? Negative 1 plus 2 is 1. 1 plus 2 is 3. So I'm going to add 2. And remember, I don't need a plus because I've got it right there. All right. First term is, you guessed it, number 9. So 9 is my first term. And then what is the pattern? Well, it looks like I'm subtracting 10 each time. Is that right? So 9 minus 10 is negative 1. Minus 10 is negative 11. Minus 10 is negative 21. So yes, I'm going to remember to hit that negative button because I need to subtract 10 each time. Okay, and I'm done with that one. All right, square number 4. We are just cruising right along. Okay, now we're going to do, these are still formulas. It's just now put in a sort of a word problem. And Khan has a lot of these word problems, but we're doing the same thing that we just did. It's just that we have word problems now. So Ivy and Andrew, oh, I thought that would be Audrey. Andrew should be Andrew. I don't know, maybe Andrew is the name. Ivy and Andrew were asked to find an explicit formula for the sequence negative 100, negative 50, 0, 50. Okay, where the first term should be f of 1. Okay, Ivy said the formula is f of n equals negative 100 plus 50 times the quantity of n minus 1. And Andrew said the formula is f of n equals negative 150 plus 50n. So who is right? So what if we put in 0 for n Okay, so what would we get? Let's see, maybe that doesn't work. Let's see, if we put in 1 for n, that should give us negative 100. So let's see who is right there. So f of 1, we're trying IVs first. I'm writing I right there. Equals negative 100 plus 50 times 1 is 0. Okay, so then that would be negative 100. So the first term is negative 100. That checks out. What about Andri? If I do f of 1 equals negative 150 plus 50 times 1, well, that does equal negative 100. So that one works too. So now we have to try the second term. If I plug in f of 2, then I should be able to get negative 50. So let's try IVs first. F of 2 equals, should be f, negative 100 plus 50. Now I'm going to plug in 2, right? Because I have 2. So 2 minus 1. Sometimes my thing doesn't write very well. Okay. So 2 minus 1 is 1. 50 times 1 is 50. So negative 100 plus 50 would be negative 50. Okay. Andri, if I do f of 2 for Andri, okay, negative 150. So that works. I should write a check mark for IVs. Plus 50 times 2. Okay. So 50 times 2 is 100. Then I get negative 50. So I still get that. So 1 and 2 check out. Okay, so we're going to go ahead and clear. And we're going to go ahead and start at f of 3. So with IV, f of 3 equals 100 plus, remember I'm at IV, so I'm right here, 50, 3 minus 1. 3 minus 1. 3, sometimes this, I write too quickly. Okay, so 3 minus 1 is 2. 50 times 2 is 100. So this would be 0. So that one checks out because our third term is 0. Okay, what about Andri? F of 3 equals negative 150 plus 50 times 3. And then that equals 50 times 3 is 150. That equals 0. So they're both giving us the same thing. So I'm going to say, so let's check 4. F of 4. I'm ready to call it, but I just want to be sure. 100 plus 50 times 4 minus 1. Okay, so 4 minus 1 is 3. 50 times 3 is 150. So 100 plus 150 is 50. So that one checks out. Okay. What about Andri? F of 4. I'm right here for Andri's formula. Equals negative 150 plus 50 times 4. 50 times 4 is 200. So 150, negative of 50 plus 200 equals 50. So that one checks out too. So, yep, it's both. Let's see if we are right. Yep. Okay. Find an explicit formula for the arithmetic sequence. Note the first term should be a sub 1. Okay, so now we are writing our own sequence. Okay, so a sub n, we know a sub 1 equals 37. And so what's the difference? We just want to cheat, do this quick. 74 minus 37. Oops. Helps if I move the mouse. 74 minus 37, because we're looking for the difference, equals 37. Okay, so can I get from 74 and can I add 37 and will it get me 111? Whoops. 74 plus 37. Will it get me that? Yes. So how about if I add 37 again? Does it get me 148? Yes. Okay, so I am adding 37 each time. So add 37. So I'm going to write, this is something you probably need to memorize, but I'm just going to take the first term and n minus 1 means take the term before. So if I plug in 1, that gives me a sub 0, that's 0, and I'm just adding 37. So if I want a sub 1, a of 1 equals a 1 minus 1, that's 0 plus 37. So that works. So let's see. I haven't punched this and I haven't really done Khan Academy yet. So we're going to see. Sometimes it likes it in this form and sometimes not. So we're about to see. So a parentheses, n minus 1 parentheses plus 37. Okay. A parentheses, n minus 1 plus 37. Okay, let's see if it works. Your answer includes a wrong variable letter. Okay, so it doesn't like this A. So, well, it is 37. So if we do 37 times n, so does that work? So if we do our calculator, if I do 1, 37 times 1 is 37. Excuse me. Clear. 37 times 2 for A of 2. Does that work? Yes. And then let's check 37 times 4. With the right numbers. Yes. So that should work. Okay, they just didn't want that A in there. All right. Now, who is correct, right? So we have Carlos and Anna. Same thing. Who is correct is what we want to know. Okay. So we're going to just do this a little differently this time. We'll do Carlos. And then we'll do Anna. And then I'm going to check 1, 2, and 4. Okay. F of 1 is, so this is Carlos's, this first one, negative 10 plus 6, because 6 times 1 is 6. And that equals negative 4. Does that check out? No, see, I'm supposed to get negative 10. Okay, let's try Anna's. F of 1, negative 10 plus 6, 1 minus 1, that'd be plus 0. So f of 1 is negative 10. Yes, that checks. So f of 2, does that check out? Negative 10 plus, so if I put in 2, 2 minus 1 is 1. So I have 6 times 1, so that's plus 6. So that it should equal negative 4. So is that right? Yes, that one checks. And then let's go ahead and do f of 4, because it's the last one. Negative 10 plus 4 minus 1, that's 3. 6 times 3 is 18. So that means it would be 8. And yes, that checks out. So it's Anna's only. And I can double check my math just to make sure. On Carlos's, I plug in 1 and I get negative 6. Negative 10 plus 6, which is negative 4, which is not the first term. So just Anna is correct. So let's check it. Yes. Okay. So explicit formula. Okay, so we have 81, 54, 27, and 0. Okay, so are we adding 27? 81, subtracting 27 is what I meant. 81 minus 27, what do I get? 54 minus 27, what do I get? 27, and then minus 27 is 0. So I am minusing 27 each time. So if I do a of n times, but I have to start at 81. So I want to do 81. Well, if we start above 81, I wonder if we can do that. 81, let's see, 27 plus 81 is 108. Will let me do that. Let's see. This is arithmetic stuff is kind of guess and check if you haven't caught on to that. Okay, so what did I say it was? 108. Okay. 108 here. I'm going to do 108 minus 27n. That way, if I plug in a of 1, and then I get 108 minus 27, which will equal that 81. So I'm going to see if Khan Academy will like my formula. So a of n equals 108 minus 27n. Okay, let's see. Equals 108 minus 27n. Does it like that formula? Yes. All right. Square number 4 done. Okay, now we're doing square number 5. Okay, let's go. Okay. Find an explicit formula for f of n. So instead of having this f in here, we want an explicit formula. So the only way to do this, we need to just list all of the sequence so we can kind of come up with a better formula. Not a better formula, just a formula that doesn't have f in it. Okay, so here we go. First term is -8. Second term, okay, so I'm finding the second term, and I'm going to take the first term, which is -8 minus 3. So I'm just minusing 3. That's the pattern. So -8 minus 3 is -11, minus 3 is -14, minus 3 is -17. Okay, so I've got the first 4. So how can I do this if I have f of n? And so I'm going to take my pattern, which is -3, and I'm actually going to take -8 and I'm going to add 3. So I'm going to pretend. So I'm going to, let's see, -8 plus 3 is actually -5. So I'm going to start at -5, and then I'm going to subtract -3 times n. So does this work? So I'm going to plug in f of 1 equals, now I have -5, and then I'm going to have -3, times 1. Okay, so -5 minus 3 equals -8. Does this work for f of 4? So -5 minus 3 times 4 is 12, so minus 12. So then that would equals -17. And yes, that's what I get. Okay, so I like my formula here. That's my answer. -5 minus 3n. Okay, let's type it in. -5 minus 3n. Okay, looks great. Okay, complete the recursive formula of g of n. Okay, so we want the first term. So we just plug in 1. So g of 1 equals, we have 1 plus 5. 1, that's 0, right? Because 1 minus 1 is 0. So then I just have 1. So g of 1 is just 1. Let's let's type that in. And so we need this is the formula to get our terms, and then this is the recursive formula. So we got to find the pattern, because the recursive formula is just recursive plus pattern. So to do that, I really need to list out the first 4 terms. Okay, so I got my first term, which is 1. Okay, now I need g of 2. And g of 2 is 1 plus 5 times 2 minus 1. So just 1, right? So that equals 6. So second one is 6. How about g of 3? What's that? 3 is 1 plus 5 times 2, right? Because 3 minus 1 is 2. Okay, 5 times 2 is 10, plus 1 is 11. So my third one is 11. G of 4 equals 1 plus 5 times 4 minus 1 is 3, which is 15, plus 1 is 16. Okay, so now I have my pattern. So what do I do every time? First, I'm going to add 5. Then I'm adding, 5, right? Plus 5, plus 5, plus 5. So I'm adding 5 every time. So the pattern is plus 5. Okay. So when we're doing recursive formula, we need to know the first term, and then we need to know what is the pattern. All right. There we go. Okay, how about this one? So we have the first term and we have the recursive formula, but we need the explicit formula. Okay. So the way I like to do this is list the first 4 terms. Okay, that's 51. And we have the pattern, right? 51 plus 2, 53, 55, 57. Easy peasy when you have the recursive formula. Okay, so the explicit formula. Like I said, there's different ways to do this. I like to pretend what would be what's before. So that would be 49, and then plus 2n, right? Okay, so if I plug in 1, that'd be 49 plus 2, which would be 51. If I plug in 2, then that'd be 49 plus 4, which is 53. If I plug in 4, 49 plus 8, 49 plus 8, 49 plus 8, 57. And yes, that's my 4th term. Okay, so I like this formula, 49 plus 2n. That's how I like to do it. There's another way to do it. You do it however you like to do it. That's just how I like to do it. All right. Next, complete the recursive formula of f of n. Okay, so I got to find f of 1 is 64 plus 6, which is 70. Pretty easy there. Remember, 4, 6 makes 10. So easy peasy. Now, what is the pattern? Remember, when we're doing recursive formulas, we ask ourselves, okay, we take the term before, and then we have to find whatever the pattern is. So I'm going to list the first 4 terms. Okay. First term is 70. Okay. Now I need to plug in a 2 to find f of 2. That is, I keep clicking that button, so 64 plus 6. Oh man, sorry. Let's undo a bunch. Let's try and make this cleaner. 64 plus 6 times 2 is 12. Right, let's do some of this in our head to make it easier on ourselves. 64 plus 12 equals 76. 76. Okay, f of 3. 64 plus, if I plug in 3, 6 times 3 is 18. 18. equals 8 plus 4 is 12. Carry the 1, right? 7, 8, 82. And then keep hitting that button there. And I should go slower so I can write nicer. Sorry, guys. F of 4. Okay. We're going to stick 4 into the formula. 64 plus 6 times 4 is 24. So then I get 8, 88. Okay, so what is the pattern? Plus 6, right? Plus 6. Yes, plus 6. Yes. So the pattern is plus 6. So that's what I need to write right here. All right, there we done 5 squares. So let's go on to the next square. We have 2 more squares to go. We are almost done for the week of math. Let's go. Okay, what is the next term of the geometric sequence? Okay, again, now we were doing arithmetic sequences, which means we add or subtract. Geometric is basically multiplying and dividing. Okay, so now we're on geometric. We're doing the same thing that we did before, but with multiplication and division. Easy peasy, right? Okay, so what is the pattern? So I have something, and I'm going to divide, right? Because the numbers are going down. What is 250 divided by 50? Okay, let's cheat because it offers us a calculator, so why not? 250 divided by 50, 5. And then if I take 50 and I divide by 5 again, whoops, that's plus, delete, divide by 5. What does that give me? 10. So again, we just need to divide by 5 for the next, whoops, which is 2. All right. So that is our answer. Okay. So arithmetic, addition, subtraction, geometric, multiplication, division. Here we go. Okay, numbers are going up, so we need to multiply. What 5 times what is 15? And everyone should know this. It's 3. So if I take 15 and multiply by 3 again, do I get 45? And the answer is yes. But I don't know what 45 is times 3. So we are going to find that out. 135. So that is our answer there. Again, we're just modern, super simple. Okay, it's decreasing. So I know I'm going to be dividing by something. 375 divided by 75. I'm looking for the pattern. Is it 5? Yes. Okay, because 75 divided by 5 is 15. But for those of you who don't believe me, I will plug it in. 15. 15 divided by 5. I don't need to plug that in. That's a fact, right? You should know it's 3. So that's my answer. All right. Here we go. 2 times what equals 10? 5. 10 times 5 equals 50. No calculator needed here. 50 times 5 is 250. And that's my answer. Easy peasy. Okay, last square of the week this week. Okay, geometric sequences, negatives and fractions. Okay, whenever we have negatives or fractions, it does make it more difficult, right? If we have something that's positive and negative, then positive, we know that we're dividing by a fraction, right? Dividing by negative. Because a negative times a negative is a positive, but a positive times a negative will be a negative number. So we need to know this ugly fraction times what equals this ugly fraction, right? But because this 9/4 and this 3 are kind of nicer numbers, that's what I'm going to use. So, but I can see a pattern here. 27 divided by 3 is 9, and 16 divided by 4 is 4. Okay, so let's see, I need some workspace here. So let me just write that down. Remember, in math, when we don't know what to do, we just write stuff down and then we can see the patterns. So this is divided by 3. And this one is divided by 4. Okay, so it could be 27 divided by 16 times, well, let me write like a circle. Okay. 4 thirds. Okay. So if you don't believe me here, if you need a little review on multiplying and dividing fractions, okay, 27 could be split up into 9 times 3. 3 doesn't like it when I draw 2s or 3s for some reason. And 16 can be rewritten as 4 times 4. Remember in math, oops, I just wrote 6 for some reason. Who knows why? 4 times 4. Remember, math, we can take any number and we can rewrite it as anything else as long as they are both equivalent. Okay. And then if I multiply this huge honkin' thing by 4 thirds, remember in fractions, the top cancels from the bottom and the bottom cancels from the top. So I have a 4 here, I have a 4 here, I have a 3 here, and I have a 3 here. So this thing simplifies to 9/4. Okay. I need to definitely throw a negative in there too, right? Because I need a negative. Okay. So now I got what I needed. Now I need to know if I take this negative 9/4 and I multiply it by negative 4 thirds, am I going to get 3? Okay. So times negative 4 thirds. Okay. So I'm going to go ahead and rewrite my 9. I'm going to write it. Can I scroll down? Maybe not. Okay. I'm going to rewrite this 9. I'm going to rewrite it as 3 times 3, right? I need a negative still. 3 times 3 over, and no need to write 4 because I have a whole 4 to cancel with, times negative 4 thirds. Well, I have 1 3 to cancel with this 3, and I have this 4 to cancel with this 4, and I have a negative times a negative. So I'm left with positive 3, and that's what I want. Okay, so my pattern is this negative 4 thirds. Okay, so I'm going to go ahead and erase this whole thing because I need more room. Negative 4 thirds, we're going to remember that. Come on, erase. Let's go ahead and erase all of this and this. Okay. Come on. All right. Doesn't want to erase that. That's okay. Negative 4 thirds. Okay, that's what I think my pattern is. So I'm going to take 3 and I'm going to multiply it by negative 4 thirds. Okay, so this 3 and this 3 cancel and I'm left with negative 4. So my next number is negative 4. Let's type it in, see how we do. Good work. So even though there are scary fractions in here, don't let it scare you too much. It's okay. Okay, so my first number is negative 1/7, but look, my denominator never changes. So that's kind of nice, right? So all I'm doing is I'm just multiplying this negative 1/7 by something. So I'm going to take this first negative 1/7 times it by negative 4 because I noticed I go from negative to positive to negative. So times it by negative 4, I get positive 4/7, right? Times by 4, negative 4, sorry, times by negative 4. So my pattern is negative 4. And now I have negative 16 divided by 7. So I have negative 16 divided by 7, and I'm going to times that by -4. Remember, when I'm multiplying by a whole number, I have an imaginary 1 in the denominator. So this 4 does not cancel with that 16. It's being multiplied. Okay, so I didn't memorize my 16 times table, so I'm definitely going to use my calculator here. And then I'm just going to plug in 16 times 4 because I know my negative times a negative is going to be a positive. So I know I have a positive number. So I'm going to go ahead and use my calculator and type in 16 times 4. Oops, that's not what I wanted. Times. So on your keyboard, that times button is actually that star above the 8. So you can hit Shift 8 to get that star. That's why I like to do it. It's a bit faster, but you can also push times right here on the calculator. Times 4. 64. Okay, so my answer is going to be positive 64 divided by 7 because that fraction is just hanging out there. Okay, that should be it. Okay, so here my numerator and my denominator are changing every time. So I'm going to go ahead and write this down so I can figure out what we're doing here. 81 over 25. Now, how would I get from 81 to 27? I could divide it by, again, if we can always use the calculator. So 80, we could do 81 divided by 27 to see what we can see. That's 3. Okay, so if I take 81 and I'm going to divide that by 3, then that equals 27. Okay, so that's really helpful. I'm going to write that down. Divided by 3. Oops, I didn't need that part. Okay. How do I go from 25 to 5? Oh, that's easy, right? Because I can divide by 5. All right. So now, remember when we're dividing, we need to kind of flip things, right? Okay. Because we want them to cancel. Okay. So I have 81 and I have 25. I'm not sure why this keeps popping up now. Sorry, guys. Times. Oh. Maybe if I get rid of this, who knows? Yep. Okay. So I want to switcheroo these because I'm dividing. So I need to swap them so that they cancel. So I have my 5 in the numerator and my 3 in the denominator. Okay. No negatives going on, so I don't need to worry about any negatives here. Okay. So if I do this, okay, I can rewrite 81. I can rewrite it as 3 times 27. If you don't believe me, get out the calculator, double check. 5 times 5 times, sorry, that's supposed to be times 5/3. Okay, so now I have a 5 that cancels on top, 5 on bottom. I have a 3 on top and 3 on bottom. So then I get 27 divided by 5. Okay, if I multiply this number by 5/3, do I get the next term? Okay, I'm going to rewrite 27 as 9 times 3. That's a math fact. Divided by 5 equal times, sorry, I don't know why I keep writing equals 5/3. So this cancels with this 5, and this 3 cancels with this 3. Do I get 9? Yes, I do. So now I'm going to have 9 times 5/3. Remember, we need term number 4. I'm going to rewrite my 9. Remember, we can always stick a 1 in the denominator because this is a whole number. Remember, I have 9 whole pizzas, so 1 in the denominator. So I'm going to rewrite 9 as 3 times 3 divided by 1 times 5/3. So what cancels? 3 cancels with 3. Now I get 3 times 5, which is 15 over 1, which means it's a whole number. So it's just 15. So that's my answer, 15. Okay, geometric sequence here. No fractions. Yay. Okay, so what do we do to go from 20 to negative 10? Okay, so I'm going to need a negative, right? So if I take 20 and I can multiply by negative 1/2, or you could say 20 divided by negative 2. Both of these are equivalent and 100% okay. Doesn't matter how you do it. I'm going to do this one, okay? Because I'm guessing most of you out there do not like fractions. That's okay. So I have 20 divided by 2 equals negative 10. And then I have negative 10 divided by negative 2 equals positive 5. And then I have 5 divided by negative 2. Okay. 5 divided by negative 2. And this is the same. Here's the fractions again, you guys. 5 times negative 1/2. Okay. So it equals 5, negative 5 over 2. Okay. You should have covered all of these division, fraction similarities in pre-algebra. Hopefully you did. If not, this is your super quick review. Okay. That you can divide by a fraction, or you can multiply by a fraction or divide by a whole number, but it's the same. Okay. Okay. So my final answer is negative 5/2. All right. So negative 5/2. Don't forget that negative. All right. Done with number 6. So we only have one more square to go. Right? Am I right? I'm like, I don't know. 1, 2, 3, 4, 5. Oh, that's it. So that's it for week 1 for Khan Academy. Super simple, lots of sequences. Sequences are really like a puzzle. You just have to keep working at them until you figure out the puzzle. They can be very frustrating. So if you feel frustrated about any of this, go ahead and skip on to the next square and see if you can figure it out. And be sure to come to my office hour and ask me questions because I am here to help you. Have a great week, everyone. Bye.